when you're designing animations, there are several things you need to be careful with. Firstly, people do not always interpret animated data accurately. So unless it's necessary, I would say statics maps would be a better choice. Okay, and if you are doing animations, you are making animations, please make them short, from 30 seconds to 1 minute. That's very good. No longer than 1 minute because it will be overwhelming. Okay, and also you want to make sure that the phenomenon you are trying to show in your animation, the change you are trying to uh, uh, address in your animation is simple. Or in other words, you want to simplify your data before making an animation, okay? And also, if you're pretty good at making animation, you may want to add some buttons in your animation to give some map control to your users. For example, a pause resume button, right? Or another slider to control the speed of the animation. Of course, this is a higher requirement. This is a higher requirement. And basically, there are two types of animations in GeoVisualization. The first type is temporal animations, which means that time is the axis of the animation. We arrange different frames. We organize frames by time and show them one by one. And there are non-temporal animations. Okay, we can use locations and or attributes to replace time to make animation. Okay, and we can also use animations to address non-temporal changes, not from 1 year to another year, maybe the change from one place to another place. Okay, and also there are zoom animations using zooming function to zoom out, zoom in to observe a specific place or places. There are fly-through animations to show you the structure of a place, to show you the appearance of a specific location or place, used from different angles. Okay, it feels like you are flying over the area. Path animations, they are similar to fly-through animations, but they use a specific object, for example, a triangle, a circle, a small period, to show you the path or paths of objects. Okay, obviously zoom animations, fly-through animations, and path animations, they are non-temporal animations because those frames, they are not arranged by time, okay, but by other things, okay. And the time and space, they are natural components, complements of one another. So when we're talking about animations in a context of GIS, of geography, usually we use time as the axis of the animation. Okay, and the most common way to make animations in geography is what is organizing frames by time, and each frame is showing a specific snapshot of a location, and we arrange them by time. So the change of space by time, and the space and time, they are both scalable. Okay, there could be I mean, the scale for space is relatively straightforward to understand. For example, your animation could be about a small town, could be about a county, could be about a state, or even a country. That's different spatial scales. Sorry. There could be temporal scale. For example, your animation is for the land cover change of a small town in the last year. Okay, that's one time scale. could be for the last decade, that's larger temporal scale, could be for the last century as an even larger temporal scale. And when we're trying to address time in an animation, this time can be the time can be represented spatially linearly, can be represented in space linearly or cyclically. For example, you can make an animation that plays only for one time, and your users need to click or implement another operation to play it again, which means that, for example, the land cover change for a small town in the last decade. Okay, so the start of the animation could be last decade, right? Could be 2010, and the animation will play to show you the land cover change of the small town by year, and then stops maybe at this year in 2020, and maybe there are projections of land cover change in this town for the next 10 years, but say it stops at 2030, and this is a linear representation of time. Or you can make your animation show this change again and again. For example, one, it shows a projection of the land cover change of this small town at 2030. That's the end. That should be the end of the animation, right? And then you can make this animation play again from the very start. So there is a cycle here from 2010 to 2020 to 2030, and then jump back to 2010 and play again. Okay, so the time in an animation could be linear, okay, or could be cyclical. And yeah, like I said, sometimes it's not necessary to make animations to address changes over time. We can also use static maps to do that. Okay, so how do we visualize change over time using static maps? We can use one map with multiple representations of a feature at different moments in time. Okay, there will be examples. Example A will be for this. We can also use multiple maps with a single representation of a feature at one moment in time. You can consider each map here as a frame in your animation. Okay, but here we do not do animation. We show these multiple frames or multiple maps in front of your viewers, of your readers, of your users. That will be good enough. They are static. They are not animation. Okay. Example here, example A, one map with multiple representations of a feature at different moments in time. The topic, the theme of this map is mean center of population for the United States. So this is one map, right? Multiple representations of a feature. So we have small purple triangles here, right? Triangle 1, 2, 3, 4, 5, 6, etc., etc. Okay, each one is a what? Is a mean center of population for US. So we have multiple visual variables to address the same feature. Each one is that feature at a specific moment in time. For example, this triangle is addressing the mean center of population of US in 1790, then 1800, 1810, 1820, until 2010. Okay, you can see that this mean center of population is moving west, which means that more and more people, they are moving west in this country. But yeah, that's the meaning of this map. But one map with multiple features, multiple representations of the same feature. Okay, each one addresses that feature at a specific moment in time. Okay, And secondly, we have multiple maps with a single representation of a feature at one moment in time. Here is an example. It's a spatial distribution of internet speed in Illinois. So here, a color ramp is used to address different internet speed. If it is green, it means the speed is good. If it is red, it means there is no service. If it is somewhere between red and green, it means the speed is okay, but it's not that fast. Okay, so yeah. At June 30, on June 30, 2010, this is a spatial distribution, and another spatial distribution on another day, another day, another day. So each day can be considered a moment in time, right? So like I said, we have 1, 2, 3, 4, 5, 6, 7 maps, multiple maps with a single representation. What's that representation in this map? Gradual changing color, or the color ramp, different colors they're used to address different internet speeds, right? We can consider them as 1, 2, 3, 4, 5, 6, 7 frames. If you are going to make an animation for this topic, you can arrange them by time, right? But here we do not have an animation. We have 7 frames. We have 7 maps. So sometimes this is even better than an animation, because animation can be overwhelming. It's very short. Your readers need to be very focused to get the change of spatial distribution within several seconds. But here, you just list all these 7 maps. Your users can take as long as they want to observe, right? And third example, varying, these maps, they are for varying temporal scale. Multiple maps with a single representation, multiple maps. Again, choropleth map, okay? A specific color ramp here is used to address different values, okay? Of a feature at one moment in time, okay? The moment in time varies in this case. This is the special part. For example, let's focus on the first 2 maps, this one and this one. Both of these maps, they are addressing the phenomenon, okay? Or the theme of the map weekly, okay? Okay. The time scale here is a week, okay? Is a week and 4 weeks. Okay, the second pair of maps showing the same topic at a time scale of month, okay? Change in 3 months, change in 6 months, okay? Then the third pair is addressing the same phenomenon by year. The left map is for a calendar year. The right one is for a water year. It's a definition. It's a concept in ecology, but you don't have to be clear with that. But what I'm trying to show here is using static maps to show changes across space by time. But this time the scale of time can change from week to month to year, okay? So one is necessary. Like I said, unless it's necessary, do not make animations. But one is necessary. You're trying to make temporal animations. Okay. Okay. Just as we typically map space to space, we can also map time to time in an animation. That's temporal animations, right? For example, we view temporal animations almost every day. For example, when you're looking at weather forecasts from TV, there is always this short animation showing the spatial distribution of precipitation or temperature using choropleth map, which means different colors. They are employed to address different values, right? So here is an example showing you the change of campus, the University of Georgia, from 1805 to 2006. So here, nothing changes except this part of the geovisualization, right? You can say there are more and more buildings. Each one is addressed by a polygon, and we also say names of all those buildings. Okay. So this is a very typical animations, specifically temporal animations, to show the change of space by time. And also, temporal animations are often better at conveying broad patterns of change than differences between particular places. Okay, which means it's better to focus on a specific place and show the change of something, of the phenomenon you're interested in across time or by time. One the general recommendations is show broad changes at small map scales, right? Small map scale map always include a larger area. Show detailed changes at large map scales. Sounds no-brainer, sounds natural, but I just want to mention that when you are trying to address something happening at low scale, you want to use a map with large map scale. Okay, for example, the land cover change of a small town or of a community. Okay, you want to use a map with very large map scale. Okay, because you are focusing on a small area, on a small place. And at last, when you are making animations, legends are also very important because you want to especially when you're trying to make temporal animations, you want your readers, your users to know the exact time right now for a specific frame. So there are different solutions. For example, solution A, you can use two circles. They're just like clocks, right? To show the month of the year, right? Or I mean, using a number or using a specific abbreviation for that month to show the specific time for a specific or several frames. Okay, and yeah, you can also use a traditional scale bar to do that. So this scale bar is using a blue bar to show you the progress of the animation, right? From day 1 to day 2 to day 3 to day 4, and more frames for day 4. And currently, this frame is somewhere between day 3 and day 4. Or simply use a mark to show that, or simply show the time using digits, right? Or specific time with a time zone to show that. Okay. A change of space can be relatively and accurately or easily sensed by your users. For example, if this animation is trying to show the change of something at different locations, when the location changes, your readers will know that. Okay, for example, your animation at the very beginning, your animation is showing something happening in Chicago, and then showing the change of the same thing in New York. People will know that, okay, suddenly the area of interest changed from one city to another. It's relatively easy for your readers to know that, but the change of time is hard to perceive. So using proper temporal legends will help people to correctly perceive the change of time. Okay, this is the last slide of the lecture for animation. Thank you for watching, and I will see you in the next lecture. Okay, see you.